Okay, so what if they give us an equation or a function in vertex form and they want us to graph it? Well, first I'm going to, over here, I'm just going to put what my generic vertex form looks like. It's a times x minus h squared plus k. And in order to figure out what the vertex, meaning the bottom of the hill, or the bottom of the valley or the top of the hill, I need to know what the vertex is using the form that's given to me. Now, this is my h, this is my k. All right? So look at your vertex form. It says x minus h. In this case, our h is actually going to have to be -1, because when I put -1 here, the minus a negative is what gives me this positive. All right? So you kind of have to, when you're doing the h, when you're thinking of the h, you're going to have to think of it as sort of the opposite of the number you see inside the parentheses. It was the same way in the last unit when we shifted left or right, and I said a shift to the left is actually a plus, and a shift to the right is a minus. All right? The h itself is actually the opposite of the number you see in the parentheses. The k is what it is. In this case, it's a -2, a -2. So the vertex is -1, -2, and I'm going to go over and I'm going to plot that vertex right now. To the left 1, down 2, there's my vertex. -1, -2. All right. Now, the next thing I want to do is identify some points that are on each side of this vertex. Okay? And actually, now that I look at this, I think I kind of have my table a little screwed up here. Let me adjust this because that's supposed to be a 0, and this one down here is supposed to be a -1. And the reason that I skip over -1 in that x table is because I already know what the y value is. I have that point already on my grid. So it wouldn't make sense for me to go ahead and find that point again. So with these x values, I'm going to take them and I'm going to plug them right into my original. Okay, my original is f of x equals 2 times x plus 1 squared minus 2. So let's go ahead and let's plug these in. Remember your order of operations. I'll do one of these, and then you can do the rest. I'm going to take my -3 and put it there. Order of operations says I do parentheses first. So my parentheses in here is -3 plus 1, which is a -2. Then I go to my exponent. -2 squared is a +4. Then I multiply. 4 times 2 is 8. Then I subtract. 8 minus 2 is 6. So when my input is 3, my output is 6. So I can plot the point -3 up 6. 1, 2, 3, 4, 5, 6. Right there. How about -2? If I take -2 and plug it into my function, -2 plus 1 is -1. -1 squared is 1. 2 times 1 is 2. 2 minus 2 is 0. So -2, 0. Oops, I went too far from that. So -2 zeros right here. Hence the 0 of a function. This is a 0 of my function. It's where it crosses the axis, and the output is 0. Now the great thing about quadratics that you'll find, in case you don't already know, is that the left side mirrors the right side. So we'll work through plugging in -1, but it should be the same thing as what I just got. Oh, you know what? When I was hitting undo, was undoing those. That's not what I wanted undone. What I meant to say was when we plug in 0, I should get the same thing as I got when I plugged in -2. So 0 plus 1 is 1, 1 squared is 1, 2 times 1 is 2, 2 minus 2 is 0, and sure enough, we do get the same thing. So this is another 0 of the function. 0, 0. And then when I plug in 1, 1 plus 1 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 2 is 6. So the right one up 6 has me here. And now we see that we have all these points that are mirroring each other. So I have that parabola shape like so. All right, so we went ahead, we graphed those points. Now, if the graph opens up, like the one we have here, a smiley face, the function has a minimum. That's the bottom of the valley. And the minimum here is the point -1, -2, which happens to be our vertex. So with quadratics, your maximum or your minimum is always going to be your vertex. The axis of symmetry now is going to be that dotted line that this thing flips over. So I'm just going to go ahead, I'm going to drop that thing in here. I got to move it a little bit because I missed. It sits right there. And that vertical line is going to be whatever the x value is that you're flipping over. It seems to me like that's an x value of -1. It's not a coincidence that that's also the x value of your vertex. So your x value of your vertex is going to be your line of symmetry. Okay? The zeros of the function, well, it's where it crosses the axis, which was here and here. Or you can look at your table and you see that it's where the output, the f of x, is equal to 0. So they appear to be at -2, 0, and at 0, 0. So the actual zeros, meaning the numbers that when you plug them in lead to an output of 0, are x equals -2 and x equals 0. Those are the values that when I plug them in, my output was 0.